Um, I'm very nervous with a panel like this, but thank you everyone for coming. And I have to say, only in Bangalore would a science session draw more crowd than any other session at LitFest, but please give yourselves a hand. Very exciting. You've already been introduced to the eminent panelists, Anil, Ananthaswamy, Annapurni, Subramaniam, Venki, Ramakrishnan, and Singh. So without any further ado, let's just get into the session, and I want to leave enough time for audience questions, so please keep all your questions in mind. We'll try and get to them. I have to say that, I'm a scientist, and as a child, I was inspired by Carl Sagan. He was an astronomer, yeah? Okay, so they used to show his program Cosmos on Doordarshan, and I think he must have inspired thousands of people to become scientists. So the fact is that children are very, very excited by science. And by the way, the quality of science at the children's LitFest is actually a slight bit better than it is at the adult LitFest. So please, go and take a look at the sessions over there. What I want to start by asking Annapurni is the following thing. So when you look at other aspects of culture like sports or the arts, there's no question about their intrinsic value. But when you look at science, people sort of see through the lens of what can it do for me. Now, astronomy is one aspect of science which escapes this particular problem because children and potentially adults continue to be interested in astronomy. So what I wanted to ask Annapurni is, as an astrophysicist and as the director of a publicly funded institution, does she think that there is some role to getting everybody, not just children, but the public at large, excited about science? How does one actually achieve this?
Yeah, first of all, thank you for inviting me here and giving me a chance to talk to you about my passion, which is just staring at the sky. So what inspired me to take up astronomy is just looking at a night sky full of stars, which I was privileged to, because I can see that none of you have the privilege of looking at the sky full of stars because of the light pollution and pollution in general as such. So I have to fight for, first, to give access to good sky. Second, setting up an instrument there to look at the sky and do science, what we wanted to do. So first of all, astronomy as such gives you beautiful pictures. So the wow factor of science, astronomy gets it very easily. Okay? But then trying to take to the next step of what you can see, what is out there, and then you invoking the why questions, how questions, what can I do, how can I do questions. So you slowly take from the curiosity you arise, you invoke in people from the beginning to how you can do it step by step. Now you can just stare at the sky and enjoy the beauty, but if you want to know more about it, what you need to do, and then how the science is done these days. So it actually gives you the entire step of starting from giving an interest or invoking an interest, inciting an interest, to actually how you get to do things. And in the process, we also communicate why it is important to do astronomy. So these questions, you'll get an entire view of why you want to start science and what excites you in part of the science, and how technology and engineering is also an important factor in moving the boundary of what we know.
So can I just push you on one point there?
Sure.
So since it is publicly funded activity, have you had to deal with policymakers to stake a claim that research in astronomy is something valuable to do with public funds?
That's right, because first of all, public funds, how you use it, what output you get is number one. Two, how you communicate to people and how much people know about what you're doing, and whether the public actually thinks that it's important to do astronomy, right? So these are the important factors considering. And when we go to the ministry, they also ask us how many people actually use your data, how many people actually can do research with your data. So giving an example, our Kodaikanal Observatory is 125 years old. We have been operating Kodaikanal Observatory for 125 years. What have we been doing? Operating 125 years is easy to say. What did you do? What did we gain from it? So if you ask that question, we have been observing from 1900 onwards, and you can imagine the technology we had then. It's photographic plates. And even if you had a photo taken in a film 10 years ago, if you look at it, how does it look? full of fungus, right? So you have to carefully store this, preserve this. We have done this. And not only that, we have now digitized the entire data, calibrated it, and made it public. So 100 years of data, more than 100 years of data is gone on public. So this data is helping us to understand the 11-year periodicity of solar activity. So if you want to study 11 years of activity, you need at least 3 cycles data, 30 years of data, more than that. So you have to collect this data systematically and disseminate it so that you can actually do it. So all the tools you need in science, like the AI, ML, etc., people apply it together. What we have given is the images. Now you need to develop your algorithms, whatever you want to do with it, to find out whatever you want. So this data is completely public. So this kind of activities have to be done to get the access to data. So in astronomy, for that matter, data democratization has really helped.
That's an excellent phrase. So in fact, if you don't know, a lot of major discoveries in neutrino physics, cosmic ray physics, solar physics, and so on have come from observatories that were based in India and have made a difference worldwide. I'm going to shift very quickly because I want to do a couple of rounds with the panelists. So Simon, second question to you. So I sat in on all 3 of your sessions yesterday. And so as Annapurni said, astronomy is not just pretty pictures. There's a lot of work happening in the background, mathematics that you've written about, biology. These are all subjects that are subtle. There's a lot of depth that you need to truly understand them. Is it possible that scientists are not the best place to actually communicate subtle concepts to the public? What is your take on this?
I'm sat next to a Nobel laureate and a professor of astrophysics. We have people here who have a genuine, huge talent, not only in their chosen professions of academia, but also in being able to communicate with the general public. And so that's fantastic, and we're very privileged to have these scientists. But I think in the UK, there's almost too much pressure to communicate your work. Scientists become scientists because they love science and they love doing science. And I don't think we should necessarily expect them to communicate their work. Sometimes grant money has money set aside for public communication of your research. And some research, you know what, isn't very interesting to the public. So I don't see why we should necessarily spend money in that way. So if you're a talented scientist who can also has a talent for communicating, fantastic. Otherwise, please stay in the lab and do your wonderful science, I would say.
So there's another angle to this. So I found that the sort of modern pressure for science communication is also seen by the public as self-serving. That is, you're out there, you're talking about your science, but in the back they're thinking this is because you're pushing your field, right? So there's a sense in which I feel that journalists, science writers are seen as the people's representatives to extract meaning from what science is actually happening. Do you see yourself as a member of the public who's trying to understand what the scientists do?
Yeah, so and I should say things have changed a huge amount. If you go back again, I can only talk about Britain, but maybe it's a similar situation here. If you go back to the 1970s, if you were a scientist who communicated to the public, then your colleagues would probably look at you in a disapproving way. It was seen as cheapening science, and every slight simplification you would make would be laughed at. Whereas now, I think the science community really appreciates those who take the time and have the talent to communicate. So that's one thing. We shouldn't discourage scientists from speaking out, but we don't necessarily need to over-encourage it. And for me, most of my writing has been about how great is mathematics, how wonderful is cosmology. And so most of my writing isn't really, political is maybe not the right word, but controversial topics like AI, people have to tread far more carefully. So having someone like Anil trying to decipher what's really going on is perhaps better than having a professor of AI, or as well as a professor of AI doing it.
Because I think in your session yesterday, you said that nothing was apolitical. In some sense, there is always some sort of value being implied by both the work and the communication of the work. So this is something all scientists maybe
I must admit, I don't remember saying that.
Okay, so maybe it was a question in the session. Okay, we'll circle back to controversial topics, but we will. Anil. So Anil has recently written a book on AI, and I have to say, of all the popular science books I've read, This one has about 10 times as many equations as any of the other books. So I don't know if you've read Stephen Hawking's Deep History of Time, which is supposed to be about the most fundamental type of all science, the origin of the universe. But there's no equations. Everything is written in words. But the fact is that science has a technical language. It has a very specific way of doing things. And among scientists, the way the conversation happens is absolutely different than the conversation that happens between science writers or even popular lectures by scientists and the public. But I think what Anil has done is very courageous, which is to actually open up the hood and show how things work underneath. And the first question, so what did your editors think about going in this direction?
Thank you for having me to begin with. You mentioned Stephen Hawking. I think Stephen Hawking in his book, he says that his editor had told him that every equation you put in the book halves the sales of the books. Yeah. And the only equation he had was E = mc square, right? And so given the number of equations in my book, I really did expect the sales to asymptotically go to 0. And I'm very, very happy to say that hasn't been the case. Sorry, what was your question again?
So I think it's a very rare choice for a science communicator to actually use, there's no difference in the way your book is written and, potentially a very good textbook in the field. Textbooks can be very, very bad, right? So this is actually an exceptionally clear documentation of how AI works. But when you started to write a book about AI, you could have chosen many different ways to do it, but you chose to do it in the language that scientists themselves use.
Okay, so I see what you're... the impetus for the book was the math itself. So I think the idea for writing the book came about quite serendipitously. I was just learning the mathematics of machine learning for my own sake, and it had nothing to do with thinking about writing about AI or ML. And when I was encountering some of the math, the writer in me woke up saying, oh my God, this is so beautiful, I really need to now communicate this. And it was not about communicating just the conceptual aspects of AI, but actually what I thought was beautiful math and rather simple math, which is what I think makes the math of machine learning amazing, is that you just need probably advanced high school level math, basic calculus, basic linear algebra. You don't even need to know linear algebra. You just need to understand what vectors are, what matrices are, and some probability and statistics. And you can grasp this amazing transformation that is happening right now, right? Maybe not all the gnarly details of what the people are doing, but at some fundamental level, you can grasp this very easily. And it was the desire to kind of communicate, all of this stuff. So the difference between what a textbook would do and what I tried to do was I also brought in the skills that, say, Simon and I have, which is being journalists, right? So one of the differences between a scientist writing a book and journalist writing the book is we do bring an outside perspective and potentially not hewing to any one scientist's point of view about what that work might be. So there is, for instance, a chapter in my book where the researcher is saying, oh, my work literally is the bedrock for all of AI that is happening. When he says it in his talks, it seems like that's the truth. But as a writer, you have the responsibility to point out that, yes, it's true up to a point, but there are other things also that are equally important. So, yeah, I think this book was entirely driven by the desire to communicate the beauty of the math. And then at some point, it became clear that I started feeling like this is something the public should actually know because of the transformation that is afoot in society. And I think we really need a lot of people to appreciate machine learning at the level of mathematics and not just based on articles you read in popular magazines.
Yeah, so it's a more accurate presentation. Great. So, he's saying you just need to know linear algebra. So I don't know if you know this, but Heisenberg didn't know linear algebra, one of the developers of quantum mechanics. Right? So physicists actually, in the early part of the 20th century, physicists would not have known linear algebra or what a matrix was. So this is some heavy-duty math in this book, but I still encourage you to read it. Just one final point before we go on.
I think by saying that, you have halved the sales of the book already.
Sorry. I love the book. But you also teach a science journalism workshop. You've taught it at NCBS for over 10 years. Do you encourage your students to do the same thing, which is to put yourself in the mind of the scientist to try and see what they're doing? Or again, like I asked Simon, is there a distance that you encourage them to maintain?
I think you have to do both. As a science journalist, really, you really need to, you're telling, your audience is the reader, right? So you're not writing for the scientists. And I keep telling my students that you're on the side of science. You're not on the side of the scientists. So you have to be very, very careful about that, right? So no matter how good the scientist, how great the scientist, you're not on their side, right? They are giving you information, but you have to be able to parse that information objectively and do your best as a journalist. You're beholden to, quote unquote, the truth, which of course is a slippery thing, and you're beholden to your readers. So I do tell them to get inside the mind of the scientist because that's the subject matter. You really need to grapple with the ideas as forcefully as you can, as truthfully as you can. But in the end, it's fundamentally about finding stories to tell because it's the stories that anchor the understanding of all of that science, and that's our job as writers. So
bring out the stories.
Yeah.
So I love that phrase. So on the side of science and not on the side of the scientist. So I'll keep that in mind for the rest of the session, and it leads to what I wanted to ask Venki, which is, so he spoke a lot. I don't know if you were at a session yesterday on his recent book, Why We Die. So I don't know if you know, but as the president of the Royal Society, at a time when the UK was going through multiple crises with Brexit and the pandemic and everything else, apart from speaking to the public directly through his books, he was actually able to speak to policymakers, give advice to governments, and they would ask for this advice. So what I want to ask is something very specific. So so you're a researcher in a very specific area, and then governments or who represent the public come to ask you about a very big question, which could take you outside your area of expertise. How do you even start engaging with that discussion?
So you don't do it on your... Can you hear me?
Yep.
So you don't do it on your own. Large policy questions are basically decided by a group of experts that are typically appointed by the council or committees of the Royal Society. They're often composed of fellows, but not exclusively. But they're experts, so for example, in climate change or pandemic and so on. And the president is simply a spokesperson for the official views of the Royal Society. So if you're a president, you can speak as a person, but you have to make that very clear that those are your personal views. Or you can speak on behalf of the society, and that's a consensus view of experts.
So just to push you a little further on that point, so the Hippocratic Oath, which physicians take, there is, in the modern version of it, there is one line which, to paraphrase, it says something like, I will advocate, it doesn't use that word, but for the best treatment I think is suitable, not just for the individual, but for society. And so it almost places a burden on the physician to make decisions and convey what they think is the right choice, which is somehow not quite how scientists are in some idealistic version perceived to be, where they are seen as at a distance and letting the data speak for itself. Now, I don't want to discuss the Hippocratic Oath, but there is a sense in which scientists in the idealistic world are not seen as advocates, but they're seen as in an unbiased way looking at the data. But we all know it's nowhere close to the way we actually deal with our own data. So for example, in the book you were talking about yesterday, there are scientists who believe there are ways to extend lifespans, and they've gone out in public and they've said, here's what I believe is true, and maybe you should try this. What do you think about a scientist putting their finger on the scales like that?
Yeah, so that is a problem. It's actually one reason I wrote the book. And because my own field is very close to the aging field, because protein synthesis, which is what I study, plays a central role in the processes of aging. And in fact, many people in my field do work directly on aging, but I don't. But it gives me an insight in the sense that I can read the primary papers. So I'm somewhat better than, say, a more naive journalist who can be spun by these people. So books on aging have been written by either journalists who are not really trained in the field, or they've been written by scientists who have an agenda. They have a company, they have a product, they have a service, they're selling something. And so, you know, I thought the field could use, given all of the hype in the field, that it could use someone who's close enough to the field but doesn't have skin in the game. And that was one of my, one motivation among many for writing the book.
Okay. The point was made that, for example, press releases can be spun in a way to overemphasize the results of some scientific publication. Anil, just very quickly, when you look at press releases, what's your instinct? How do you read them?
Oh, I don't trust press releases at all.
Okay.
No,
Okay.
I mean, you as a journalist, absolutely not. I mean, you know it's coming from an institution, right? They have an axe to grind. So you have to be, you're tuned to be skeptical of these things and do your own reporting and research as much as possible. I agree with Venki that some of the science can get really hard. So at some point you have to rely on the integrity of the scientist who's explaining the stuff to you, and if they are trying to spin, then you're in a bit of a soup. But by and large, you always triangulate your sources.
Yeah.
I will never ever take one source at their word.
Sure,
You know,
but,
so-
but I have read books, previous books on aging by journalists.
Yes,
And
no,
I can tell
I'm
you,
not saying that it doesn't happen.
They're somewhat uncritical.
Yes.
Because they're not able to read the primary papers. That's the problem.
Yeah, so, and that can absolutely happen, but you know, if you are really being an honest and serious journalist, you want to triangulate your sources. You just definitely don't want to rely on a single source. Even if you don't understand the primary papers, if there is a piece of information that's coming from some primary paper, you want multiple people to explain that to you so that you can see that the explanations are all tallying up.
Okay. So, Annapurni, you've written popular articles about astronomy, right? And I know that it's not as politically loaded as climate change or aging, for example, but it's still a sense in which you, as a scientist, are speaking to the public. So over there, do you see yourself as a member of the public or as the scientist who's trying to explain things?
I think I would wear multiple hats at that point, because first I would write as what I want to convey as a scientist, and then I have to, assume that I'm a reader, and then read it as much as I can. Of course, there is bias, but then you have to read it, and then am I actually able to convey what I actually wanted to convey in the writing, right? So then, ideally, would pass it around to someone who is not related to the field, and want to get a feedback from them. Hey, this is what I want to do, but am I actually conveying out there? All right. So then you are almost like this triangulation method of you taking roles of two people and then getting some feedback, and then making sure that this is actually conveying what you actually want to convey. Yeah.
Who do you get the feedback from?
My family members are the first targets, and they are actually good critics. And then, of course, friends at times, because then they're not scientists, but they are readers and they're well aware of the field or the situation. So they give me good feedback on even the language used, or whether the idea is coming out properly or something like that. Because as you rightly said, you are biased against certain things, and you're not able to understand whether you are putting across properly, or it's too heavy, or too light, or things like that. So yeah, I do this kind of three-point triangulation thing to make sure that it comes out. Yeah.
Okay. So in fact, that language, there are words that you see in a scientific paper like uncertainty. Uncertainty just means, I don't know if this value is between the 5% and 95% interval. But if you write uncertainty in a popular article, it means, I'm not sure what's going on, right? So even the very use of words is something that scientists, you may not know because you're stuck in this sort of expert speak. And unless you really take it out, and I'm not sure, so of course, as I'm sure as critical as your family is, this is actually something I found very difficult in trying to write to the public, is that I honestly feel that I do not know how the words are being read. And I personally haven't found a way to solve this problem.
I also tell you, I find it difficult when we do, the request for proposals, like a commercial stuff you're publishing. and you want to put an item on what is the scientific requirement and justification. And then a scientist or an engineer writes it. It's a lot of technical terms. And then I have asked someone to read it from the finance ministry or Department of Expenditure. And they read it and said, this is absolutely, these words mean something completely different to them. So you have to use the right words even in that case. And I said, good Lord, this is not correct, and we need to have some terms which are read the same way and understood the same way across the table. Otherwise, the whole document is interpreted in a different way. So language as such and the words you use are very critical.
So David Spiegelhalter, who is the former president of the Royal Statistical Society, he was at NCBS a couple of days ago, he gave an example of the Bay of Pigs invasion when John F. Kennedy was deciding what steps to take. Apparently, he had an assessment of the chance of success, and the answer was 30% chance of success, 70% chance of failure. But instead of writing those numbers, the report said a fair chance of success. And apparently, fair means like 30%. Whereas he thought fair means, oh, that's pretty good, we should go for it. And obviously, it didn't, it wasn't numerically accurate. Simon, I think one problem with science journalism is not due to the journalists at all, but it's just due to the time frames. You have to have, something is newsworthy, you have to have the story in a short time. There is a press release, there are a few sources you can consult. So there's a sort of short and rapid dissemination of science. And then, of course, there are books, which is completely the other end of the spectrum. It could take you 20 years to write a book. And then there's everything else in between. What, in these days, digital and with the people looking through many other sorts of sources of information, what do you think is the collection of most efficient ways to communicate accurate scientific facts?
So we have newspapers, and newspapers, their job is to sell copies. Their job is to make money for their owners. There are some exceptional examples that run against this. People like News Laundry have an online newspaper, and their coverage of science and politics more generally is terrific. Subscription-based. If you can buy a subscription, buy a subscription. But more generally, newspapers are there to sell. So if you can make something sensationalistic, if you can make something that's scaremongering or the latest miracle cure, you'll make the headlines. And if you're the journalist who's taking too long over your story or asking too many questions, then you're never going to get published. And even if you do write a reasonably good article, the chances are the headline will be completely misleading because journalists don't get to write the headline. But the good news is, so I think the general public is very poorly served. They're misled left, right, and center over the latest nightmare story on climate change or the latest technology that's going to save the world. Okay, it's almost impossible for the general public to navigate science and technology. Online, you have wonderful resources, longer format material that's really well researched by fantastic journalists. It is a universe of fantastic science journalism out there, of all forms, of all types, at all levels. And then there's also the same old rubbish that you get in the newspapers, except probably 3 times as bad. And people fall into their echo chambers and they hear the stories they want to seek out, and they're in the WhatsApp groups that link to the stories that mislead them. So it's a very confusing time. So going back to what Venki was saying, that his role and his colleagues in terms of informing government is incredibly important because in Britain, things have improved over the years. We're now in a situation where every government department has a sort of head scientist, somebody who informs that department, whether it's the Department of Trade or the Department of Agriculture. They have a lead scientist in that department, as well as a chief scientist across the whole of government. And that person should never dictate policy. They're a scientist. But the evidence, I don't mind people saying evidence-based policy. It's not evidence-dictated policy, but it's evidence-based or evidence-informed policy. Because, there are lots of political questions that need to be addressed. What's financially viable, what's ethically viable, what the public will accept, the timeframes of an election, and so on. But at least if the facts are there on the table, then the government can't make a decision and say, well, we didn't know. So I think the most important thing is that the governments, at least, are getting the science right. And in some cases they do, and in some cases they don't. And I said yesterday, and I'll say it again, in America, well, in Britain, we've had homeopathy on the NHS for a while. It's disappearing fast, but it's something we should have been hugely embarrassed about. In America, they've got RFK, anti-vaccine propaganda and so on, all sorts of nonsense. And here in India, you have the Ministry of Ayush. So, you know, governments get it badly wrong sometimes, and the more that scientists can do to speak out, the better.
So I saw you nodding to some of the, did you want to respond to that?
Yeah, no, I do agree with him. And by the way, my previous comment about journalism, journalists span a very wide range. I mean, I've greatly admired Simon's books on the code, on cryptography and Fermat's last theorem, and I'm looking forward to reading Anil's book on AI. But there are fields where you are susceptible because the facts are not clear, there's lots of money at stake, and that's where, unless you're right in the field, it's really hard to make judgments. But in terms of sort of general science communication, I think, yes, it's incredibly important for scientists to be able to communicate to government about what is our current state of understanding and where are the uncertainties. And that was really seen during the COVID pandemic. I mean, even Trump had to, I mean, at least in the early stages, was really promoting the vaccine program, you know, did initiate lockdowns, did listen to Fauci for a while before things got a little strange. So I think, you know, it is very important.
Okay. I want to leave enough time for questions, so I'm going to go one final round. I just want to ask everybody on the panel. We all were inspired to get into science in some way. Could you describe, was it a book, a teacher, something else? What inspired you to somehow, your interest in science, assuming we all have an interest in science?
So I think for me, my interest in math probably goes back to a high school teacher. But honestly, through most of my schooling, the teaching was not inspirational. I think the interest in science really began when I started working as a software engineer and found myself getting bored with software and reading about science. So some of the, you know, when we talk of scientists writing, I think I would partly sort of agree with Venki and disagree with Simon a little bit about scientists writing. Some of the best books that I've read that inspired me to become a science writer were by scientists themselves. Like when I think about Feynman or Steven Weinberg, Carl Sagan, you mentioned Carl Sagan, Stephen Jay Gould. I mean, there are lots and lots of examples of scientists doing exemplary communication, right? And of course, journalists and science writers also. So for me, the inspiration has really come much later than my early education.
Interesting. Annapurni?
Yeah, mine's a bit different. My parents are musicians, Carnatic musicians. So my parents, both of them vocalists. So all the time, what happens at home is music. Either it's classes or teaching, or I'm sitting and taking notations, etc., all music. But I was inspired by a teacher in school to take up science. But what about astronomy is the night sky of Palakkad, because there's something called, we used to have power cuts. Thanks to power cuts, we could actually see lots and lots of stars. And I used to, Palakkad is very hot, so the exams are in the summer. So I used to get up in the morning and study. And I used to look up at the center of the galaxy, Sagittarius, and did not know what it was. Always used to get up and see that the cloud was there or not, the same position. And then I started looking up at the star charts, the night sky charts from Hindu, used to cut from the library, bring it, identify the constellations. So that was inspiration for me, because my parents did not know anything about either the stars or the sky or the science itself. Yeah, thank you.
Not what I was expecting. So power cuts. So I said Carl Sagan, but I also have to say my physics teacher from school is in the audience. And so she's over there. But this is not about me. Venki.
Sorry?
Who inspired you?
As a scientist?
As a scientist?
Well, I mean, a lot of people, but say Feynman was one of them. You know, that's one of the reasons I went into physics.
Simon?
Yeah, it's Carl Sagan, Richard Feynman, and I had a fantastic maths teacher as well, so it's kind of what makes everybody as their teachers, absolutely.
Okay, great. I think we're going to close the panel with that. Thank you so much. And we're going to go for questions. So I hope somebody's running around with a mic. And this gentleman in the front row has had his hand up for a long time. So we'll start with that. Please, short questions and hold the mic close.
Can you hear?
Yeah.
The question is just to Venki, sir. There was a time when there was no life on Earth at some period of time.
Yeah.
There were only elements: carbon, hydrogen, oxygen, nitrogen. Is it possible to exactly decipher how these elements combine to form proteins that form the basis of life and life systems? So that there are only elements:
Sure,
carbon,
yeah.
hydrogen. Okay.
So how did atoms...
Origin of protein.
How
did life begin?
How did life begin? Okay, that's an easy question. Okay,
That's
Venki, that's to you.
That's a great question, and if I answered that, I'd be really famous. You know, so I could, you know, that's a question that people have been working on for a very long time, and I would say they've made progress in the sense that they can figure out how you can get the building blocks of life from simpler chemicals which might have existed in a prebiotic atmosphere. But what they haven't been able to do is figure out how that leads to a sustained self-replicating system. And that's what people are working on. And one of the people working on that is Jack Shostak, who's done a lot of work. Another is a colleague of mine, John Sutherland.
So there is a lot of work going on. So keep reading the papers. There's a young man over there. Okay, somebody has the mic, and there's somebody. Can we have his question next? Go ahead.
Good evening, sir. So I have a question to Professor Venki Ramakrishnan, sir. But before that, I just want to comment on like what Simon sir came just like quickly go through Ministry of Ayush. So fundamentally, I think like Ministry of Ayush or like whatever, people have such a misconception about like, you know, they think, I just have very simple example. For example, if my friend asked me, Ki, what did you have lunch? And I say, I had 2 tablets of protein, 1 tablet of carbohydrate, 1 tablet of this. No, I ask, I had 2 chapatis, a bowl of rice and this. So it is more natural way of system. The more it is like, it's more science. If we go into more research area, we will be able to.
Question,
so,
please.
Yeah, so just I want to highlight that. Now, yes, my question is to Venki sir. So sir, as we know, in protein structure and all those things, we are getting more and more close to computational biology. The more and so I just want at that time, if there was AlphaFold and all those, you know, like new AI models to build.
Okay,
look,
protein
this
structure.
is not really about this session. You're not talking about science writing and communication.
Okay, actually,
right?
that's a good point. So let's keep the questions in the domain of the panel. There, could you stand up?
You can ask me that later.
You can.
Okay.
Back there, the yellow shirt behind.
Can you hear me?
Yes, a little louder though.
Yeah. Thank you so much for your time, and I'm sure all of you are very busy. Having spent a lifetime and grueling hours doing research or journalism, how do you handle internet experts who just do a Google research or pseudoscience motivated by religion or politics?
Okay, I mean, also maybe Anil, how do you handle internet experts? People who go and Google and believe that they found the answer to a complex question.
How do I handle that?
Yeah.
I don't really
He doesn't
listen
talk
to
to them. He's not on any WhatsApp groups.
No. So, I mean, as a journalist, you don't want to depend on internet experts at all. You really want to.
So I think it's a legitimate question. A lot of people are surrounded by friends and family, for example, who get their information from dubious sources. How do you speak to them to explain? Yeah.
Yeah, I think the real problem is that the level of scientific literacy in a culture determines how much people are going to be susceptible to these kinds of ideas. And as science journalists, science communicators, as scientists, I think it's our role and responsibility to make sure that, you know, that level is constantly raised.
Fine. Are we losing the battle?
I think we're losing the battle right now.
Okay.
Yeah.
Bad news.
I think it's not a solved problem.
It's not. It's an unsolved problem. It's an important but unsolved problem.
Hi.
I'm not sure who's handing out the mics, but okay, go ahead.
Hi, I'm Hoysala. So I wanted to pose to these science ace experts what they think, what their take on the simulation theory is.
That we all live in a simulation?
We all live in a simulation. This isn't
I mean-
a matrix. What's your take on it? A scientific take, hopefully.
So again, sort of not quite in the domain of the panel, so I'll ask maybe other people, can you hand very far away on that side? The lady over there. If you could just run through, pass the mic down, Thank you so much. There you go.
Thank you. My name is Deepa. I'm a science journalist and one of the early beneficiaries of Anil's science journalism workshop. My question is mainly to the scientists, but Anil also can weigh in. As a science journalist, what I found is, when I write about a scientist's work, and I always take their interviews and I share a draft with them, and they also go to check the science, that the science has been accurately represented. But ultimately, when it is published, there is also like kind of my own interpretation of it, and the editor also has a say in what part of the science gets highlighted, and some parts may not get highlighted because you have to take into consideration the reader's interest.
Question.
The question is that scientists often nitpick on that. So I wanted to know your take on it.
So maybe from both sides. So when you write to a scientist and they sort of, so do journalists write to you and you go back and you edit their draft? Is that something you do?
A lot of journalists won't allow that. They won't send me the draft. And I can see why, because of this problem of they don't want to be spun by me, right? And so I can see why they don't do it. But sometimes they take a nuanced thing and they simplify it, which is fine, but they oversimplify it sometimes, which is not fine, because it ends up being wrong or having sort of an incorrect balance. So it is a problem, but there's no really good solution to it.
No, but this is a good question between simplification and oversimplification.
So I made a film about Fermat's last theorem for the BBC, which you can still see if you can access the BBC iPlayer. You can watch it. And in that film, John Conway, the great mathematician, absolute god of mathematics, tried to explain why a computer could never prove Fermat's last theorem. And in the film, he says, if you prove Fermat for 10 numbers, there's infinitely many left. If you prove it for 100 numbers, there's infinitely many left. If you prove it for 1 billion numbers, there's still infinitely many left. Now, when we filmed him, that's not what he said. What he said was, if you prove it for 100 primes, there's infinitely many left. You prove it for 1,000 primes, there's infinitely many. You prove it for 1 billion primes. Now, my problem as a science journalist, filmmaker, was that I didn't know whether the viewers would know what a prime is, okay? I think most would, but some wouldn't. And also, are there an infinite number of primes? How many people know that, okay? And also, why is just proving it for primes enough, okay? These are quite technical questions. So when I was editing the film, every time he said the word prime, I took it out. And somewhere else where he said the word numbers, I put it in. And nobody ever noticed. Nobody ever noticed. And I didn't ask John Conway for permission because I think he would have said, no, that's what I said, and if you don't like it, then don't use it. And I think he would have been wrong. I think he would have been wrong. And after the film was made, he never noticed, he never commented on it, and I got away with it, I suppose. Now, for me, as Anil said at the beginning, we write for the viewer. I don't want to lose the viewer. I don't want to confuse the viewer. I don't want them to be misled. I'm not saying that black is white and white is black. I'm simplifying the mathematics. And so it's a hard line to tread, and we don't always get it right. But I think if we're trying to be honest, we're not trying to over-promote something or sell something. We're trying to be honest, but also just trying to help the general public. And some people would disagree with what I did, but for me, it was the right thing to do.
It's interesting. Here, there's one question here. Can we take that, please? And then maybe just a last there. You get the last one. Okay.
My question is on the astronomical aspect of science. That is it true that star twice the size of the central star of our solar system, that is Sun, has been swallowed by a black hole, as per print media reports, and about the central star of our solar system, that is the Sun, let's suppose its weight is 1 kg, it has shed 5 grams, 10 grams, because of which the gravitational force
So-
with which it pulls the closest planet, Mercury, towards it has decreased.
So I'm going to reinterpret that question. When somebody reads in the newspaper that star A has swallowed star B, does that properly convey what the event would have actually been like?
Yeah, for instance, I had to convey something like a one star eating up the other star in a binary system.
Right.
So I had to introduce something called a vampire star, because it's not a vampire at all, and it's nothing wrong with the star that it's
vampire.
swallowing. But yeah, so we have to introduce something which is more commonly used to convey the concept of the matter being sucked in. But I think he has a technical question which needs to be answered separately.
Okay, so unfortunately, this timer says we have 10 seconds left, 20 seconds. So I'm just going to stop and say, please keep coming to these science sessions whenever you can in public, because that's the only reason LitFests and other public fora will continue to have them. You've been an amazing audience. Thank you, Anil, Annapurni, Venki, Simon. Thank you for coming.